Good day, everyone. Today, we are going to discuss the first subtopic under the mineralogy, which is the elementary knowledge on symmetry elements of crystallographic systems. So let's get started. But the first question is, why do we need to study crystallography? Crystallography is useful for the identification of minerals. It is also the study of crystals that can provide new chemical information. Also, crystallography is of major importance to a wide range of scientific disciplines, including physics, chemistry, molecular biology, material science, and mineralogy. It is very useful for solid-state studies of minerals. It is also important in crystal heating therapy. So what is crystallography? Crystallography is simply a fancy word meaning the study of crystals. It is the study of crystalline solids and principles that govern their growth, external shape, and internal structure. Crystallography is easily divided into three sections: geometrical, chemical, and physical. So if crystallography is the study of crystals, what is a crystal? Here is one definition of a crystal. A crystal is a regular polyhedral form bounded by smooth faces, which is assumed by a chemical compound due to the action of its atomic forces when passing under suitable conditions from the state of a liquid or gas to that of a solid. After knowing the definition of crystallography, let's move on to the crystal systems. The crystal systems are a method of classifying crystals according to their atomic lattice or structure. The atomic lattice is a three-dimensional network of atoms that are arranged in a symmetrical pattern. The shape of a lattice determines not only which crystal system the stone belongs to, but all of its physical properties and appearance. There are 7 crystal systems or groups, each of which has a distinct atomic lattice. These are cubic, trigonal, tetragonal, orthorhombic, hexagonal, monoclinic, and triclinic systems. The first crystal system is the cubic or isometric system. In this crystal system, the 3 crystallographic axes are all equal in length and intersect at right angles to each other, or all 3 axes are equal in length and all are perpendicular to one another. Cubic or isometric system is based on a square inner structure. The next crystal system is the trigonal or rhombohedral system. In this crystal system, all 3 axes are of equal length, and none of the axes is perpendicular to one another, but the crystal faces all have the same size and shape. It is also based on a triangular inner structure. Tetragonal system. In this crystal system, there are 3 axes, all at right angles, 2 of which are equal in length and 1 which is different in length. In another definition, 2 of the 3 axes are equal in length, and all 3 axes are perpendicular to one another. This crystal system is based on a rectangular inner structure. The next crystal system is the orthorhombic system. In this crystal system, there are 3 axes, all at right angles and all 3 of different lengths. In other words, all 3 axes are unequal in length, and all are perpendicular to one another. This crystal system is based on a rhombic or diamond-shaped inner structure. Hexagonal system. In this crystal system, there are 4 axes. 3 of the axes fall on the same plane and intersect at the axial cross at 120 degrees between the positive ends. These 3 axes are the same length, and the 4th axis is different in length. It is based on a hexagonal or 6-sided inner structure. The next crystal system is the monoclinic system. The three axes, all unequal in length, two of which intersect at an oblique angle, and the third axis are perpendicular to the two axes. This crystal system is also based on a parallelogram's inner structure. The last and seventh crystal system is the triclinic system. The three axes are all unequal in length and intersect at three different angles. Or, in another definition, all three axes are unequal in length and none is perpendicular to another. This crystal system is based on a triclinic inner structure, meaning three inclined angles.
Now let us move on to the symmetry of crystals. Symmetry is a set of mathematical rules that describe the shape of an object. Do you know that there is only one object in the geometrical universe with perfect symmetry? Infinite planes of symmetry pass through its center. Infinite rotational axes are present, and no matter how little or much you rotate it, on any of its infinite number of axes, it appears the same. It is the sphere, and the sphere is the holy grail of symmetry. Symmetry is the consistency, the repetition of something in space and or in time. Specifically, in finite objects, there are a number of operations describing repetitions and are called the elements of symmetry. These are the plane of symmetry, rotation axis of symmetry, and center of symmetry. Plane of symmetry. Any two-dimensional surface that when passed through the center of the crystal divides it into two symmetrical parts that are mirror image. It is simply like the concept of a mirror, where the image is found perpendicular to the reflection plane and equidistant from that plane on the opposite side of the plane. Next is axis of symmetry, an imaginary line through the center of the crystal, around which the crystal may be rotated, so that after a definite angular revolution, the crystal form appears the same as before. Depending on the amount of degrees of rotation necessary, four types of symmetry are possible when you are considering crystallography. There are four types of axis of symmetry. First is the binary or twofold symmetry. It is when rotation repeats form every 180 degrees. Second is trigonal or threefold symmetry. This is when rotation repeats form every 120 degrees. Third is tetragonal or fourfold symmetry. This is when rotation repeats form every 90 degrees. Fourth is the hexagonal or sixfold symmetry. This is when rotation repeats form every 60 degrees. The last element of symmetry is the center of symmetry. Most crystals have a center of symmetry, even though they may not possess either planes of symmetry or axis of symmetry. Triclinic crystals usually only have a center of symmetry. If you can pass an imaginary line from the surface of a crystal face through the center of the crystal or the axial cross and it intersects a similar point on a face equidistant from the center, then the crystal has a center of symmetry. It is also called the inversion center, where each part of the object is moved along a straight line through it to a point at an equal distance from the center.